lesson is very short, like the rest. It's going to be on single replacement right there. Okay. Now we've done, you've done writing chemical equations. We've done balancing chemical equations. And then we did chemical types of chemical reactions last class period. We talked about 6 different types of reactions. We talked about acid-base reactions, precipitation reactions, synthesis reaction, decomposition reaction, single replacement reaction, and combustion reaction. Those were the 6 types of reactions we talked about. Now today we're going to zero in on single replacement reaction. We're going to see how to use the activity series to predict if a single replacement reaction would occur. Now it's very simple. If you're able to understand the activity series, it makes the work very easy. So I'm going to click on today's lesson, single replacement. Now, lesson objective. At the end of this lesson, the expectation is that you will be able to use the activity series of methods to determine if a chemical reaction will take place. We're going to look at what is the activity series. So, very small, brief background. Now, if you look at the cup, this picture you see in front of you, that's a picture of a silver cup. You can see how ugly it's looking because it's undergoing chemical reaction. Silver is an element, and it's a metal. And what happens is that silver is reacting with the hydrogen sulfide in the atmosphere. And when it reacts with the hydrogen sulfide in the atmosphere, silver replaces hydrogen in the hydrogen sulfide gas in the atmosphere. So that's what is causing this ugly looking colors that you see. And that's an example of a single replacement reaction that occurs all around us. Now, we're going to look at the activity series. And the activity series could be used to predict if reactions like this can occur. So on the next screen, you can complete this. On the next screen, you have a picture of the activity series. Now, activity series simply involves elements that are arranged in order of their reactivity. So if you look at this example we have here, you can see as you're going from top to bottom, the activity or reactivity of the metals decreases. So what this means is that the elements on top are more reactive than the one at the bottom. Lithium here is the most reactive metal in this activity series. So which means that lithium can replace all the other elements that occurs beneath it. So lithium can replace rubidium, can replace potassium, barium, strontium, all the way down to gold. Now, look at the example we have here. Magnesium plus copper nitrate. Now, what happens here is that magnesium is higher in the activity series than copper. It therefore means that magnesium can replace copper in copper nitrate because magnesium is more reactive than copper. That is why you have copper now displaced, and then you have magnesium nitrate. Now, if you look at the second example reaction, gold, Au plus HCl. Au is here at the bottom of the activity series, is beneath hydrogen. Because Au is beneath hydrogen, Au cannot replace hydrogen in this compound. Therefore, this reaction will not proceed. That means there won't be any reaction because gold cannot replace hydrogen. So this, now take note here, hydrogen is part of the metals activity series because hydrogen behaves like a metal. Hydrogen, rather than share electrons, it gives away its valence electron. That's why it's regarded, or that's why it's placed in the activity series of metals, because it acts or behaves like a metal, although it's a non-metal. Now the second half is the activity series of non-metals, right here. This consists mostly of the halogens, that group 17 or 7A, and also include phosphorus. You could say the same thing, similar to the metals. The non-metals are arranged in order of their reactivity from most reactive to the least reactive. So which means that fluorine here, being the most reactive of the non-metal, will replace all the elements that have been knitted. An example here is sodium bromide and fluorine. Now, fluorine and bromine will trade place because fluorine is more reactive than bromine. So fluorine can replace bromine and to give you sodium fluoride and bromine gas. So that's how you use the activity series to predict if the reaction would occur. Now let me give you an example on the next one that you're going to work on. You can watch this video later. If I click on there, it gives me the activity series in a very clear format. Now we are asked here to identify which reaction would occur. I think this is all messed up. Okay. Let me fix this. We are asked here to identify which one would occur. So we're going to drag and drop. We're here together. Now, we're going to use this activity series to predict which of these reactions would occur. Now, the first example here is zinc reacting with copper sulfate. Now, you're looking at copper and zinc. Will zinc replace copper in this reaction? So if you look at your activity series, look at where zinc is. This is zinc right here, up here. And then at the bottom here is copper. So based on that, you could say that zinc can replace copper because zinc is more reactive than copper. So that reaction will proceed. So which means that zinc will replace copper to give you zinc sulfate, and then copper will be by itself. So I'm going to drag zinc sulfate in there because that will be the product of this single replacement reaction. So if you check, that should give you a correct answer. So that's what you're going to do with the rest. You check and say which one can replace the other element or metal in the compound. If it's high in the activity series, that means the reaction will occur. That means it can replace it. And then you go ahead and enter in the product once that element is able to replace the other element in the compound. And that's what you do here, predicting if the reaction will occur and what the product of the reaction will be. Okay, now this is for metals, and then the next one is for non-metals. You practice with the non-metals. The same thing you do if it's high above, for example, chlorine plus sodium bromide. Now, chlorine is a non-metal. You're going to compare with the non-metal which is bromine. Don't compare with sodium. Okay, so chlorine, when you compare it to bromine, you could say that chlorine is high on the activity series than bromine. Bromine is at the bottom. Therefore, chlorine can replace bromine in sodium bromide to give you sodium chloride and bromine gas. So I'm going to look for sodium chloride, which is this, and bromine gas. If I put it right there, I check, I should have it. All right. Okay. Please do it before you know what, I'm going to disable show solution so that you can try it and don't just look at the answer. Okay. And that's all I have for you on single replacement reaction. Any question for me? Hubert, a question? Joseph?
No.
Question for me now? Vivian, you have question for me?
No.
No? Lisbeth?
No, I don't have a question.
Okay, Bill, okay. What about Brian? Belinda, you have question for me? All right. So if there are no questions, I will let you complete the rest. You can remain logged in while you work on it so that if you have questions, you can take advantage of me being here and ask so I can help you out.